or one example C2H6. First one, alkanes. First one is this alkane, and in this alkane, if I ask you one thing, alkanes are more reactive or less reactive? Alkanes are more reactive or less reactive? Alkanes are more reactive or less reactive? Even I can say that these are the least reactive molecule. In general, what I said, least reactive molecules that we are discussing in organic. In general, I can say this thing. So if they are less reactive, then they prefer to go only one type of reaction, which is named as free radical substitution reaction. What I said is which reaction? This one, free radical substitution reaction. And in this case, how to identify this reaction may either take place in presence of heat, or maybe in presence of, I can say, UV light, or maybe in presence of, I can say, electricity, like that you found UV light, heat, electricity, UV light, like that you found. Any one of the representation you found. Clear to everyone, yes or no? Here again, F2, Cl2, Br2, I2. These are the four halogens. Order of reactivity. This is order of reactivity. Order of which one? Reactivity. What I said here, this is order of reactivity. Here again, two questions. Fluorination usually avoid. Why fluorination usually avoid? Because of its strong bond formation. Reaction become highly exothermic. What I said, because of its which one? Strong bond formation, reaction become highly exothermic. While about this side, iodination also not possible directly. So to make this one possible, this need oxidizing agent. What this one need? Oxidizing agent, that may be either HNO3 or maybe either which one? HiO3. So means which reagent we required for iodination? So reagent for iodination will be most as per NCERT what they are using here, I2 plus which one? HNO3. What reagent we need here? I2 plus which one? HNO3. Clear to everyone here? No. Last thing now, order of reactivity of hydrogen. What I said word here? Order of reactivity of hydrogen. Order of reactivity of hydrogen. Order of reactivity of hydrogen. So order of reactivity of hydrogen will be which one here? 3 degree, 2 degree, and then which one? 1 degree. 3 degree, 2 degree, and then which one? 1 degree. Now let's say we are having this question, and here this is reacting with this. Everyone, right now, is this reaction possible or not possible? Right now, is this reaction possible or not possible? Right now, this reaction possible or not possible? Very good. Why not possible? Because here, which is not given condition, that is what we need here, either UV light, either photon, anything at least needed or not. Now, reaction now possible or not possible? Now reaction possible or not possible? Now reaction, very good. Now, if this is possible, tell me now, this carbon, 1 degree, 1 degree, 1 degree, 2 degree, and this is which one of 3 degree. Clear to everyone, yes or no? So now in this case, this 3 degree will react and directly you will get one product, this one. This one is a major product. This one is which product here? Major. Still you will get some minor product. Still you will get some minor product. Clear to everyone, yes or no? Any confusion till here? Any confusion till here? Now last way of preparation, that is which one? Halogen exchange reaction. What I am saying here? Halogen exchange reaction. What I am saying here, which one? Halogen exchange reaction. Halogen exchange reactions are of two. First one is Finkelstein reaction. What word I said here? Finkelstein reaction. Finkelstein reaction is used to prepare. Finkelstein reaction is used to prepare for the preparation of alkyl iodide. This is used for the preparation of which one? Alkyl iodide. Follows which mechanism? SN2. In general, follows which mechanism? SN2. So in this case, what we need? Let's say Rx. This X may be either chlorine or maybe either which one? Bromine. Reacting with what? NaI. Reacting with which one? What? When this react with NaI, then what you will get here? What you will get here? Ri plus which one? NaX. Ri plus which one? NaX. Now everyone, in this reaction till now, if I said like that, then this reaction is found to be highly reversible. What I said, this reaction is found to be highly reversible. Why I'm saying this thing? Everyone this side, I, good nucleophile, and even I is a good leaving group also. I'll send you that QR code in last. Please let me teach. So here what I'm saying, so this I minus can replace easily X, or I can say that I can also be replaced by which one? X minus. So problem is what? Whenever this reaction is going in this direction, parallel this shifted in which direction also? Backward direction. But here if we want to prepare alkyl iodide, means what? Yield should be more or less. What I said here, yield should be more or less. Yield should be more only. So to make this yield more, we are using here one specific type of solvent, and that solvent prevent which reaction? Tell me now. That solvent prevent which reaction? Backward or forward? That solvent preferred, I can say prevent which reaction? Backward reaction. That is why here we are using which one? Acetone. What we are using here, which solvent? Acetone. What happened in this acetone? In acetone, NaCl and NaBr, NaCl and NaBr are more soluble or less soluble? NaCl and NaBr are more soluble or less soluble? Less soluble. So what I can say, this will get precipitate out. If they will get precipitate out, means what? Now backward reaction possible, or most of the reaction will shift in which direction? Forward direction. Clear to everyone? Yes or no? And this again followed which mechanism? SN2. Clear? Yes or no? So which solvent we are using here? And acetone. In acetone, without acetone, okay, dry acetone will be there. Now next, second, what I am saying here, if I said here Schwarz reaction. Again, Schwarz reaction is used to prepare for alkyl fluoride. Which one? Alkyl fluoride. Again, this also follows SN2 mechanism. This also follows which mechanism? SN2 mechanism. Here also again Rx plus. Here what we can use now? We can use either AgF. We can use either Hg2F2, we can use either COF2, or we can use either SbF3. So many are there. You can read in NCERT, any one of them can be used, AgF, Hg2Ft and COF2. Now in this case, directly product will be which one? RF. 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 Here you can say that one more, SbF3. So this is first how we are preparing alkyl halide. Now second thing, preparation of aryl halide. Preparation of which one? Aryl halides. Preparation of which one? Aryl halides. First one, by direct halogenation. First, what I am saying here, by direct halogenation. By direct halogenation. What I said here, first one, by direct halogenation. So in this reaction, what I am saying, direct halogenation means what? Benzene reacts with X2 in presence of lowest acid. In presence of which one? Lowest acid. Most of the time which Lewis acid we are using here? Anhydrous AlCl3. Most of the time which Lewis acid we are using here? Anhydrous AlCl3, and then directly you will get here one of the product. And remember again here X, again which one? Either chlorine or either which one? Bromine. Direct halogenation cannot prepare which type of compound? Direct halogenation cannot prepare which type of compound here? Fluorobenzene and iodobenzene. Direct halogenation cannot prepare which one? Fluorobenzene and which one? Fluorobenzene and which one? Iodobenzene. Remember that one? So to the prepare for those compound we are using one specific type of reaction which is from diazonium salt. From which one? Diazonium salt. So first thing clear to everyone, yes or no? Means direct only. Second reaction from benzene, diazonium salt. What I am saying here, from benzene diazonium salt. Second precursor is from benzene diazonium salt. So what is benzene diazonium salt? That everyone knows. So when 1 degree aromatic amine, means what? Aniline reacts with NaNO2 plus HCl, or if this is not written, maybe they can write this thing here, what? Nitrous acid, and temperature range should be how much? 0 to 5 degrees Celsius. Now they will convert into which one? Benzene diazonium chloride, benzene diazonium chloride, benzene diazonium chloride, and this is now used for the preparation of a lot of compound. Directly I am writing here. First one, if I use here copper powder along with which one? HX. This X may be either chlorine or bromine. Then here you will get one of the product, and this reaction is named as Gattermann reaction. Which reaction I said? This one, Gattermann reaction. Second, if I use like that here, Cu2X2, means what? Again this will be what here? X will be again chlorine and bromine. Again you will get here which one? Halobenzene. Now this time this is named as which reaction? Which reaction here? Sand-Meyer reaction. Which reaction I said? This one here? Sand-Meyer reaction. Which reaction I said? This one here? Sand-Meyer reaction. Next, if I said here, I'm using first here which one? HbF4, hydro, yes or no? Fluoroboric acid. Now here, this first converted to N2 plus BF4 minus. When this will get heated, then this will directly convert it to which one? Fluorobenzene. Remember this thing or not? Now next, if I directly use here potassium iodide, then here you will get iodobenzene. What you will get here? Iodobenzene. One more I'm writing here. Let's say I'm writing here CuCN. Then this become CN, or if I'm using here warm water, what I said here, warm water, then this will give you phenol. Or if I said this also here, if I'm using here, which one left here? Yes, reduction, H3PO2 or either ethanol, then this will directly give you benzene. Then this will directly give you which one? Benzene. These are the reactions from which one only? Benzene diazonium salt. Clear to everyone? Yes or no? Any confusion till here? So here we completed now. One of them is there, NaNO2 also nitrobenzene, that you can also prepare. So here we completed till now preparation of aryl halide, and even most of the things also we completed. Now come to its chemical properties. Which properties I am saying first here? Chemical properties. So first chemical property, reaction with metal I am saying first. What I am saying here? Reaction with which one? Metal. Reaction with which one? Metal. Everyone, here you found two metal. Here you found two metal that may be either with magnesium. Which one? With magnesium, or either will be with sodium. With magnesium, now they are forming one of the specific type of compound which is named as a Grignard reagent, RMgX. Which reagent I said this one as a Grignard reagent? Which reagent I said this one? Grignard reagent, which is called as RMgX. Now, can I say here like that this magnesium insert in between R and X? Can I say like that here magnesium insert in between which one? R, X or not? Here if this magnesium insert in between R and X, then can you tell me that if we are having RF, RCl, RBr or Ri, among all these cases where this will be easy to insert? Fluoride, chloride, bromide, iodide. In which one most easy to insert? This one. Very good, iodide. So order of formation of a Grignard reagent will be this or not? Order of formation of which reagent? Grignard reagent. What I said this one, order of formation of which reagent? Grignard reagent. One last question here only. If we are having this case, one side chlorobenzene or one side cyclohexyl chloride. Now in these two cases where this will be easy to prepare, chlorobenzene or cyclohexyl chloride, chlorobenzene or cyclohexyl chloride, chlorobenzene or cyclohexyl chloride. Yes, very good. B only. Why? Because of resonance. Here partial double bond character or not. Here I can say that its bond order increases due to resonance. Its bond order increases or not? And if its bond order increases, then I can say its bond length decreases. So in which case this one is easy to insert. The second one. First part clear to everyone, yes or no? Grignard reagent, yes or no? Now second thing, with sodium metal. With which metal? Sodium metal. Here total 3 names you found. With sodium metal total how many names you found here? First one will be Wurtz reaction. Second one will be Wurtz-Fittig reaction. And third will be Fittig reaction. Total how many are there? 3 cases. All of them are writing parallelly. First will be Wurtz, then will be which one? Wurtz-Fittig, and then will be Fittig reaction. Clear to everyone, yes or no? Now, Wurtz means what? In this reaction, what you found? Rx reacting with sodium metal, again with which one? Rx. And here what solvent we are using? Dry ether. Here also which solvent we are using here? Dry ether, and here you will get R plus which one? NaX. R plus which one? NaX. Now some points regarding this one. This reaction is used to prepare which type of reaction? Symmetrical alkane. Symmetrical alkane means what? What I said here? Symmetrical alkane means what? Those alkanes which are having odd number or even number of carbon. Even. I'm not saying that we cannot prepare here odd carbon containing alkane. In case of unsymmetrical alkane, mixture of product form. What will form here? Mixture of product form. Therefore, this reaction avoids to use for the preparation of which alkane? Unsymmetrical alkane. And one last point, by this one methane cannot be prepared. By this one which cannot be prepared, methane cannot be prepared. Clear to everyone or not? So here directly I'm asking you one question, answer me. Let's say I'm having here this question. CH3Cl reacting with C2H5Cl, and here I'm writing sodium and dry ether. How many total product will form in this reaction? How many total product will form in this reaction? Very good, 3. First product name I'm writing CH3. Let's say I'm writing this one R1. This one I'm writing like to R2. Easy to get like that, yes or no? So first possibility, R1 with R1. R1 with which one? R1. R1 means what? Can I say this is methane? Sorry, R1 means what? Can I say this is ethane? R1 R2 or R2 R2. These are the possible combination or not? These are the possible combination or not? Clear to everyone? Yes or no? Clear to everyone? Yes or no? Now next, what's fitting? In this case now, one will be alkyl halide and one will be aryl halide. One will be alkyl halide and one will be which one? Aryl halide. Here also solvent same, dry ether, and here you will get this product, alkyl benzene. And last, alkyl benzene reacting with sodium, same solvent we are using here, and here you will get biphenyl. What you will get here? Biphenyl. What you will get here? Biphenyl. Clear to everyone? Yes or no? Clear to everyone? Yes or no? Clear to everyone? Yes or no? So now this is preparation or reaction with which one? Metal. Now next, after this one, next I'm giving you 2 brief discussion, then we will start directly equation. This is alkyl halide, Rx. Alkyl halide, most of the time you found saturated or unsaturated. In general, here I'm talking about which one? Saturated you found, yes or no? If they are saturated, then here they may either go substitution reaction or they may either go elimination reaction. Remember or not? Most of the reactions for alkyl halide will be of which type? Most of them I'm saying. I'm not saying these are the only 2 possible. But when you check most of the question from this one, then you found they're having mostly which one? That may be either which one? That may be either which one? Substitution, or maybe either which one? Which one? Elimination. Now, in substitution, in your syllabus, you found 2 reactions, one of them SN1 or one of them SN2. Substitution, most of them you found, substitution you found how many types? SN1, or second will be which one? SN2. Elimination, again you found which one? E1, or this side you found which one? E2. Clear to everyone? Yes or no? SN1, SN2, E1, E2. Name everyone, remember or not? How? First thing, to differentiate them. Let me give you one example for this one. Let's say we are having here this compound. Is it clear to everyone or not? Ethyl chloride. So in ethyl chloride, this carbon having partial positive charge and this chlorine is partial negative charge. This chlorine is a leaving group or not? This chlorine is a which group here? Leaving group. Now, so if this is reacting with nucleophile, then this leaving group directly substituted. But if this side, we need to form this product. I'm writing now 2 product. This one like this. And this side product will be which one here? As per substitution. CH3, CH2, and let's say I'm writing here which one? Nucleophile. These are the 2 possibilities or not? Any confusion till here? Either this can go substitution, either this can go elimination. These are 2 possibilities to everyone, yes or no? So if this is going through substitution, yeah, either going through elimination, then what is the difference in between them? Dekhna beta idhar. If I said in second case is which one here? This one or not? So here we break which bond? This 1 sigma bond, and this how many sigma bond total we break? Breaking 2 sigma bond, one of them sigma CH, one of them sigma Cl. We are breaking how many bond here? 2 bonds, sigma CH and sigma Cl. Here we are forming which bond? Here we are forming which bond? One of them pi CC and one of them sigma HCl. Can I say like this or not? So this side we are breaking 2 sigma bond, and this side we are forming sigma bond plus pi bond. Sigma bonds are stronger bond. Sigma bonds are which bond? Stronger bond. Sigma bonds are which bond? Stronger bond. So I can say they need more energy to break. They need more energy to break. But when these bonds will form, comparatively less energy releases. What I said here, comparatively, what energy releases? Less energy releases. If this is like that, then can I say in this reaction net energy will be absorbed? Net energy absorbed means what? This side reaction become endothermic reaction. Which type of reaction? This one. Endothermic or not? And now everyone knows endothermic reactions are more favorable at which temperature? High temperature. Therefore, elimination reaction substituted through heat from which reaction? Substitution reaction. How to distinguish them? How to distinguish them? How to distinguish them? With heat or not? How to distinguish them? With heat or not? If we need to substitute, if we need to distinguish whether this is substitution or whether this is which one? Elimination, then what we have to check here first, whether heat is given or not. And now last thing, SN1 characteristics I'm asking you. SN1 two-step reaction or not? Mechanism I'm not discussing here, not. Time is not sufficient. What I'm saying here, SN1 is two-step reaction or not? Tell me everyone, yes or no? Out of these 2 steps, first step was carbocation formation or not? So I can say that here formation of carbocation is which one here? RDS. And next I can say that rearrangement possible or not possible? Rearrangement possible. And next I can say here racemization take place or not? Racemization take place or not? Next, what I can say here, polar protic solvent needed or not? What we need here? Polar protic solvent. These are the most common reaction. Now, rate of reaction is directly proportional to stability of which one? Carbocation. What I said next one, rate of reaction is directly proportional to what? Stability of carbocation. So here I can say that 3 degree, then 2 degree, and then which one? 1 degree. 3 degree, 2 degree, and then which one? 1 degree. Now tell me about condition for SN2. Everyone tell me about condition for which one? SN2. In SN2 what you found? Single step reaction. Clear to everyone or not? Single step reaction. Single step means what? You remember that? No intermediate formation. No intermediate formation. I can say next thing, if no intermediate formation means what? No need to check rearrangement. No need to check which one? Rearrangement. Now, rate of the reaction is depending on stability of transition state. What I'm saying, rate of reaction depending on now which one? Stability of which one? Transition state. Very good. If I said here, its transition state is pentavalent. Its transition state is which one? Pentavalent, but having sp2 hybridization. Having which hybridization there? sp2 hybridization. Last thing here, which type of solvent here we need? Polar aprotic solvent needed. What we needed here? Polar aprotic solvent needed. Clear to everyone, yes or no? Polar aprotic solvent examples I'm writing here, maybe you will get confused. One of them acetone, one of them DMF, one of them DMSO. Clear to everyone, yes or no? Acetone, DMF, DMSO, so many are there, but mostly you found in NCERT first two, acetone or either which one? DMF. Clear to everyone, yes or no? So these are the features of which reaction here? SN1 and which one? SN2. Now tell me about E1 or E2. What is difference? In E1 or E2, in E1 or SN1, only one difference is there, heat. In E1 or E2, sorry, in E1 or SN1, what difference is there? Only heat. First, in this reaction, formed product is alkene or not? In this reaction, formed product is which one? Alkene or not? Whether this is E1 or whether this is which one? E2. E1 or E2, formed product will be which one here? Alkene or not? So now in this case, two types of alkenes are there, either Hoffman or either which one? Sedgev. That may be either which one? Hoffman or either which one? Sedgev. In general, what is the way how to differentiate them? Which one is Sedgev alkene? More alpha H or less alpha H? More alpha H or less alpha H? Very good. More alpha H containing hydrogen is known as which one? Sedgev alkene. Less alpha H hydrogen is known as which one? Hoffman alkene. And last thing, E2. For E2 we need which base here now? Strong base. What we need here for E2? Strong base. One thing I left here, that in this case inversion take place. In SN2 reaction, what will take place? Inversion take place. Remember this thing, in SN2 reaction, what will take place? Inversion take place. Strong base, generally you found first alcoholic KOH. In place of alcoholic KOH, maybe sometime you found like that ROH or RO minus. Maybe you found NaNH2, ammonia. These are the strong base that is used. NaNH2 with which one? Ammonia. Clear to everyone, yes or no? I'm writing now 2 questions or 3 questions to differentiate them so that we can easily answer also. Let's say I'm having here one alkyl halide, this one. How much degree? How much degree? 3 degree. How much degree? 3 degree. So if this is a 3 degree, then among these SN1, SN2, SN1, SN2, E1, E2, which one eliminated? Answer me that same sequence. SN1, SN2, E1, E2, which one eliminated? I said, which one eliminated? Without checking anything. So here, which one is strictly not possible? SN2. Clear na beta, yes or no? Which is clearly not possible here? SN2. If you remember, SN2 was 1, 2, 3. Rest of them are 3, 2, 1. Remember this thing or not? Rest of them are which one? 3, 2, 1. So which one we eliminated directly here? Which one we eliminated directly here? Which one we eliminated directly here? SN2. Now if I said like this only, what I said here now, H2O. Other than H2O, do you found here anything? No. So now this prefer to undergo which reaction? SN1. This prefer to undergo which reaction? SN1. Why? Because this is which type of solvent here? Polar protic solvent. Which type of reaction? This one here? SN1 reaction. Now in SN1 reaction, first step was carbocation formation or not? First step is what? Carbocation formation or not? If this is carbocation formation, then what I can say here, next step will be what? Rearrangement check or not? Rearrangement check or not? Is it possible? In this case, rearrangement possible. Bolo, yes or no? So if not possible, then directly we can attach here nucleophile, that itself here solvent. That itself here which one? Solvent. Clear to everyone? Yes or no? Clear na beta? Yes or no? Now next, if I said like this, alcoholic KOH. Alcoholic KOH, sometime in NCRT, maybe you found that heat is not given. But if you found an alcoholic KOH, then prefer to follow which reaction here now? Substitution or elimination? Substitution or elimination? Which one? Elimination, because this is again strong base. Obviously heat required for this reaction, so maybe sometime you don't found. Still they are not giving, then consider this one strong base, and strong base prefer to go which reaction? E2 reaction. Which reaction I said? This one, E2. So now in E2 means what? A beta elimination or not? E2 means what? Which one? Beta elimination or not? So which hydrogen we have to eliminate now from this one? Beta. Let's say this is your alpha carbon, this is beta 1, this is also beta 1, and this is which one? Beta 2. So how many types of product will form here? Two products. One of them will be this side plus one of them will be this side. Check yes or no. Now here this having only how many alpha H? 5, and this having how many alpha H here? 9. So which will be the more stable alkene? First one or second one? 9 alpha H? Yes or no? So this will be your which product here? Major. This will be your which product here? Major. This will be your which product here? Major. Now let's say, clear to everyone, yes or no? Now next question. If I said here this one, first, without writing anything, tell me in this molecule how many types of reactions are possible? Substitution, yes or no? Tell me. Substitution, yes or no? Yes. Substitution, yes or no? Yes. Elimination, yes or no? Elimination, yes or no? Elimination. This is your alpha carbon and this is your which carbon? Beta carbon. Clear to everyone, yes or no? So in this case, beta hydrogen not available. So this only undergo which reaction? Nucleophilic substitution reaction. Now this is depending whether this may be either SN1 or maybe with one either SN2. But here product will be same or different only. So but I'm writing here this can show which one also? SN1 and SN2 both. Depending on the condition. Yes or no? Next. If I said this one, tell me now in this case, which reaction possible? Under normal condition we are talking about. In this case, SN1, SN2. SN1, SN2. I can eliminate, yes or no? SN1, SN2 I can eliminate. Even under normal condition with normal base, E2 is also not possible. Clear enough? Under normal condition, E2 is also not possible. Elimination possible here, but that is easy to proceed or difficult to proceed? Easy to proceed or difficult to proceed? Difficult to proceed. Easy to proceed or difficult to proceed? Difficult to proceed. Clear to everyone, yes or no? But in this case, I can clearly say SN1 or SN2, both of them are not possible. Clear to everyone, yes or no? Clear to everyone, yes or no? So this is which one now? Chemical properties of haloalkanes. Chemical properties of which one? Haloalkanes. Now last section, which one is? Chemical properties of haloarenes. What I'm saying here, chemical properties of which one? Haloarenes. Chemical properties of which one here? Haloarenes. So in haloarenes, first one, I'm writing here two molecules. One aryl halide and one side alkyl halide. These are the two molecules or not? Among these two molecules, both of them are having here leaving group. Both of them are having here which one? Leaving group. What they are having both of them? Leaving group. Now, first one, aryl halides are less reactive than alkyl halides. Then which one? Alkyl halides to substitution reaction. How? In this case, first thing, partial double bond. What I said here, partial double bond. This side, single bond. Next I can say phenyl carbocation. Phenyl carbocation, this one, is not enough stable Phenyl carbocation is not enough stable. Alkyl is comparatively, what I'm saying here, more stable. Next, benzene is nucleophilic in nature. Benzene is which one? Nucleophilic in nature. And here this is not having nucleophilic nature. Clear to everyone or not? And last thing, that carbon of this one having which hybridization, and this side carbon having which hybridization? sp3. These are the some of the points which are given in NCERT, that why aryl halides are less reactive than alkyl halides. Now everyone, first what I am saying here, nucleophilic substitution reaction, yeah, better I am saying here ARSN, yeah, SNAR, whatever you are saying, nucleophilic aromatic substitution reaction. I'm saying this one SNAR. Clear to everyone, yes or no? So in this case, this is benzene connected to, let's say, chlorine. Here this is less reactive, that I already said, yes or no. Why this is less reactive? Because of those 4 reasons, yes or no. So this reaction under normal condition possible or not possible? If this is reacting with NaOH, so here temperature will be very, very high. How much temperature? Sorry, 627 Kelvin, or pressure will be how much? Check, 300 atm, 623, 627, whatever is there. Clear to everyone, yes or no? Now in this case, first you will get this thing, and then after hydrolysis, this finally converted to phenol. Clear to everyone or not? In this reaction, this is acting as a electrophile and this is acting as a nucleophile. If this is nucleophilic substitution reaction, then this is acting as an electrophile. So now when this will be a better electrophile? When we will attach here electron donating group, electron withdrawing group. Electron donating group, electron withdrawing group. Let's say first case this one, second case this one, and last case this one. Among these, which one is a better electrophile? First one, second one, or third one? Better electrophile, which one? First one, second one, or third one? First one, second one, or third one? So order of reactivity will be this or not? Order of reactivity will be this or not? Order of reactivity will be this or not? Means if I said this is reacting with NaOH, this is reacting with NaOH, and this is also reacting with NaOH. All of them are reacting with which one? NaOH. Product will be clear only in all cases. But if I said here T1, temperature T2, here temperature T3, in which case reaction will be requiring least temperature. Means what? Order of T1, T2, T3. Highest temperature. Highest temperature. Highest I'm asking. T1 highest, na? Why? Because here only one group. Here how many groups are there? 2. Here how many are there? 3. So order will be which one? T1, T2, and then which one? T3. T1, T2, and T3. If you remember, in this case, intermediate, in this reaction, what was the intermediate? What was the intermediate here there? Carb anion. So therefore, I can say rate of reaction is directly proportional to stability of which one? Carb anion. Not point what I'm writing here. No role of leaving group here. No role of which one here? Leaving group. And last what I'm saying, rate is directly proportional to electron withdrawing and inversely proportional to electron donating. Rate is inversely proportional to electron withdrawing. Sorry, directly proportional to electron withdrawing and inversely proportional to which one? Electron donating. Clear to everyone, yes or no? Last, electrophilic substitution reaction. Electrophilic aromatic substitution reaction. In this case, rate is directly proportional to stability of which one? Stability of which one? carbocation, and carbocation directly stabilized by electron donating and destabilized by which type of group? Electron withdrawing group. Clear to everyone? Here intermediate, yeah, I can say here this carbocation having another name also, which is called as which complex? Sigma complex, or which ion also maybe you found? Arenium ion. Sigma complex, arenium ion. Remember this thing, yes or no? Now first thing here, chlorine. First question that you found in NCERT, is this chlorobenzene or not? Is this chlorobenzene or not? So in this chlorobenzene, this Cl group is plus I or minus I? Minus I. Is this Cl can show plus M also, yeah, plus R also or not? Answer me. Cl can show plus M or plus R or not? If this is minus I, then if you remember, in case of halogens, which one is dominating? In case of halogens, it's minus I is dominating or not? So first thing, these groups are called as a deactivating group. What I said here? Which type of group these are? A deactivating group. But which directive? Which directive? Ortho-para-directive due to which one? Plus R or plus M. Clear to everyone? This is ortho-para-directive due to which one? Resonance, which is shown by which one? Chlorine. Which is shown by which one here? Chlorine. Now answer me. Simple question. Let's say first I said here chlorobenzene. One example. Cl2 anhydrous AlCl3. Name of the reaction. Concentrated HNO3 plus H2SO4. Next, what I can say here, CH3 Cl anhydrous AlCl3, and last what I am writing here, CH3 COCl anhydrous AlCl3. These are the reactions. First one is named as halogenation or not? First one is named as halogenation or not? Here you will get two products. One of them which one? One of them which one? Ortho-dichloro, and one of them which one? Para-dichloro. Which one is major here? Para-dichloro. And in NCERT here you found one line that para-dichlorobenzene is symmetrical in nature. Para-dichlorobenzene is symmetrical in nature, which can be easily distinguished from ortho-dichlorobenzene because of its melting point difference. Melting point difference means what? Having large difference in their melting point. Clear? Now next, para-nitrochlorobenzene, major only I am writing now. And next, Friedel-Crafts alkylation, para-methyl chlorobenzene. And last will be this one or not. Clear? Yes or no? So this is all about which one? This chapter I try to complete most of the thing, but still not possible to complete everything. You can revise by yourself remaining things. QR code I'm giving you. Okay. Thank you all.